First mark on this question for drawing a tangent should be straightforward. Make sure you have a ruler, make sure you've practiced doing these, and make sure that your tangent is only touching your curve at the point that it's supposed to. At this case, it's where t equals 0. So you can see on here that tangent has been added, and from there we can actually start to work out what some of the details are, what some of the figures are. So I've worked out, as I go from 0.5 and it goes through 10, quite neatly, I have a y value and I have an x value. I can see that I've got 0.5 to 0, so my y is 0.5, and my x is 10 take away 0, which is 10. From there, I can work out the gradient, which is change in y over change in x, which is 0.5 divided by 10. Now that's going to be important for what we're going to see on a future page. You can see here I've actually transferred it on. Deduce the initial rate of reaction. So the initial rate of reaction is what the line would be had it been a straight line at 0. So I've got the figures here. I put them in and I get my initial rate, as I've already shown the calculation, of 0.05 mole dm to the minus 3 s to the minus 1. The experiment is repeated at the same temperature and with the same initial concentration of B, but a different initial concentration of A. And the new initial rate was 1.7 times greater. Calculate the new initial concentration. It's a 2-mark question, so hopefully that's showing you there's not a huge amount to do on here. Let's have a look. I've rewritten down here the rate that was shown at the beginning of the question. Rate equals k times a squared times b. Now, I know that b is constant. I also know that k is constant because I'm not changing the temperature. B I know is constant because the question tells me that. So it means that I know that if the rate increases by 1.7, then A is going to go up by root 1.7 because I can see the rate to A squared relationship. Now I also know that my initial concentration of A was 0.5. I take that from the graph. So my new concentration of A is going to be root 1.7 multiplied by that 0.5. And that's going to take me to 0.65 moles per decimeter cubed.